Okay, so let's do an example, a simple example with the modified version of Kepler's third law. In this example, the distance from the center of the object m, which m is what we're looking for, the distance from the center of the object r here is 3.7 times 10 to the 8th kilometers, and the period is a little more than a year, 423 days, let's say. Okay, so both of those need to be converted into the proper units. R has to be converted into meters. That's a pretty straightforward conversion. I'll do it right here. So we know that in 1 kilometer, kilometer goes in the denominator, of course, because we have to cancel this kilometer. There is 10 to the third meters. So the kilometers now cancel. 10 to the 8th times 10 to the third, of course, is going to be 10 to the 11th. So this is 3.7 times 10 to the 11th meters. Okay, so that's we're all taken care of there. Let's work on this days. Of course, it could have been years. We could have started with 1 point so many years, but in this case, I just gave it to us. I gave it this example in days. So we know that in one day, there is of course 24 hours. There's the hours. And we know that in 1 hour, there's of course 60 minutes. And remember, we use MIN for minutes. M by itself is reserved for meters. Okay, and then we know that in 1 minute, there's 60 seconds. Okay, so this one we will need the calculator to do the calculation of seconds. And let's focus in on that a little bit. Let's see. Trying to get it to zoom in a little bit. Okay. Well, so much for that. All right, anyhow. So this is 423 days times 24 times 60 times 60, in other words, times 60 squared. So we get that many seconds. What is this? 1, 2, 3. So it's like 36,547,200 seconds. So that's in our calculator. That's what the period is. Okay, so the period. We'll just do an approximation here. So it's about 3.65 times 10 to the 7th seconds. Okay. So we're going to use that in the modified version of Kepler's third law. Okay, so this is what we're plugging into. So m is equal to 4 pi squared times our 3.7 times 10 to the 11th meters. Now we have to cube that, divided by big G, which is of course 6.67 times 10 to the minus 11th, times what we just calculated for the period, which is 3.65 times 10 to the 7th seconds, and we're going to square that. Okay, so here I'm going to do this in the on the calculator. Let me try this one more time. It's supposed to zoom. Alright, well, hopefully you can see those numbers. Alright, so that's already in our calculator. I'm going to keep that in there. So here we go. 4 times pi squared times our distance, which is 3.7, times 10 to the 11th, and we cube that. And then, see, what I'm going to do now is divide by the period squared, okay, because that's already in my calculator. So divide by the answer squared equals, that's not the answer. What I've just done is this portion, okay, so I've just done all of this. So the thing that's in my calculator still has to be divided by big G. All right, so there it is again. So that has to be divided by 6.67 times 10 to the minus 11th, And there's our answer. So the mass of this object, this is very likely a star. That doesn't matter right now. Anyhow, this is about 2.24 times 10 to the 31st. Okay, hopefully you can see that. Let me write that answer down, and that'll be the end. Okay, so this is equal to 2.24 times 10 to the 31st, and the answer, of course, the mass is in kilograms. All right, very nice.